So today we are going to cover one-way analysis of variance. We are going to do a demo using Rice University's demonstration website. So first, let's start with the hypothesis for the one-way analysis of variance. In this case, we are going to be looking at three groups or three different populations. So the null hypothesis is that the means of the three populations are equal, and the alternative is at least one inequality. The test statistic is F, and that is a ratio between mean square between and mean square within. And if the computed F statistic is greater than the critical value, then we reject the null hypothesis. So on the left-hand side, let's look at this demo here. There are three bars here. These are group 1, group 2, group 3. And the samples, there are 4 samples from each group we are taking. Sample values go from 0 to 10 for all the three groups. And the sample values are marked by these little black mark here. So those are the 4 data points here. 4 data points for group 2, 4 data points for group 3. And the mean, this red little bar, is the mean for group 1, 2.5. This is the mean for group 2, which is 5.5. This is the mean for group 3, which is 8.5. And the grand mean is 5.5. So now let me explain within and between sums of squares. So in order to do the within sums of squares, what we look at first, these 4 data points from within the first group, and we take the deviation of all these data points from the mean red, and then we take the square of the deviations, add them up. So that is number 5. And we do the same thing for group 2, same thing for group 3, and then add them up. So 15. So that represents the variation of all the data points within each group, and then now it is pooled for all the three groups together. And the between sums of squares, so what we do is here we have got 3 means here for the groups, the mean 2.5, the mean 5.5, the mean 8.5. So we want to take the variation between these 3 group means. The way we do that, for the first group, we take the deviation of that group mean, which is 2.5, from the grand mean, 5.5. Take the deviation, square that, and then multiply that by the sample size 4. So that is 36. For group 2, the mean is 5.5, grand mean is also 5.5, so the difference is actually 0. And then for group 3, the mean is 8.5, grand mean is 5.5. Take the difference between the two, square that, and multiply that by the sample size. So this 72 represents the sums of squares between the groups. So in the analysis of variance table, we take the sums of squares between, that is 72. And then the degrees of freedom, we've got 3 groups, so the 2 degrees of freedom between the 3 groups. So we divide the sums of squares by degrees of freedom to get the mean square between. And for the within, we had 15, that's the sums of squares, the within. And then the degrees of freedom, for the first group, there are 4 data points, so there is the degrees of freedom is 3 for these sums of squares. And 3 degrees of freedom for group 2, 3 degrees of freedom for group 3. So 3 plus 3 plus 3, 9 degrees of freedom. Then we divide the sums of squares by degrees of freedom, that's a mean squared. And then we take the ratio of these two, that's F statistic 21.6, the p-value is 0. So with the p-value of 0, the conclusion is that we will be rejecting the null hypothesis, which intuitively you can see that 3 group means are significantly different. So intuitively you would expect that to reject the null hypothesis, and that's what we are doing here. And if you look at this little picture here, what we are plotting here is the total is 87. So this total pi, that's 87. Then the blue part is 72 out of 87 is between sums of squares. And then the 15, it is a within sums of squares 15, so that's what that is. So sometimes we look at the total sums of squares and then we look at the percent between and percent within to give us an idea of the relative magnitude sums of squares between versus within. And you can see the blue is significantly higher than the black. So then also you intuitively see that the between variation a lot higher than within. So that means that the means of the three groups are significantly different. So we would reject the null hypothesis. Okay. So now let's look at another data set number 6. And here we have got 8 data points from each group. The data values go from 0 to 15. And if you look at the data points, these 8 data points for all the three groups, they are exactly the same. So the means are exactly the same. So the mean is 8, 8, 8 for the three groups, exactly same means. And then if you look at the deviations, sums of squares of deviations of the data points from its mean for the first group, and then you sum it up, that's 168, and it's exact same thing for the other two groups. And then the between, you see that the means of the three groups are exactly 8 each. So the grand mean is also 8. So if you subtract the grand mean from the each group mean, each one is going to be 0. So between sums of squares is actually 0. So if you compute the degrees of freedom, same as before, 2 degrees of freedom between. Within is we've got 8 data points, so 7 degrees of freedom for each. So 3 times 7, 21. And f value 0, p value 1. So that means that we do not reject the null hypothesis. And that is intuitively, it is obvious because the three group means are exactly the same. So intuitively, you would not reject the null hypothesis. And if you look at the breakdown, overall total sums of squares 504, but then all of them, they're within sums of squares, there is no 0 between sums of squares. So the total pi, the total sums of squares, is exactly same as the within sums of squares. So that means that there is nothing left for between sums of squares. So again, pictorially, you can see that we do not reject the null hypothesis. So in summary, we have demonstrated that between sums of squares and within sums of squares using this demo. Thank you.